Welcome to the free Introduction to Structural Composite course. High Peak Courses are a British government registered learning provider with the UK RLP. Hello, I'm Warren Leigh. Welcome to High Peak Courses. This free introduction to the design and analysis of structural composites is suitable for student and graduate engineers who have little or no knowledge of engineering composite materials. Lecture 2, The Merits of Using Composites, Structural Composites. I've designed this course based on over 40 years' experience in worldwide engineering. The main focus of the Structural Composite course is on the initial design and composite component sizing. No matter where your interest lies in composites, whether it be manufacturing, design, analysis, management, or cost control, in any sector there exist great opportunities for you. The use of composite materials is growing yearly. Although the main focus of these courses is on initial design and sizing of a composite component, it would be good for you to have at least a basic understanding of how a composite design can be started. To have knowledge about what factors affect the tailoring of the composite, and to ensure your composite component will be strong enough and approach the minimum weight and be cost efficient. Slide 5. When making metallic objects, sometimes it's necessary to weld different parts, different shapes together to get a complete structure, or even bolted. With composites, one of the advantages can be to reduce all these number of parts to one part only by moulding the complete shape. The manufacturability of composites implies that the material can be affordably moulded into a complicated shape and offer part count reduction opportunities. Slide 6. One apparent benefit of the use of composites is their high strength to weight ratio, i.e. lightweight. The density of stainless steel is typically 7.8 grams per cc. Now carbon fibre composite has a low density of 1.8 grams per cc. Slide 7. The strength of carbon fibre when not in a resin is very high, up to about 3,000 newtons per millimetre squared. You can see the strength of steel here is about 500 newtons per millimetre squared, which is nominal. It varies greatly around that figure. Aluminium also is far less, around about the 190 to 235 for typical aluminium, but aluminium can also be stronger than that value. Carbon fibre, when combined with a resin to form a composite, you will find that the strength is reduced. Slide 8. Note that the stress-strain diagram for isotropic materials generally is initially straight up to point P, which is its limit of proportionality. This is referenced to the applied load and the material strain. After point P, the isotropic material can still take stress, but now its behaviour is following an eventual failure curve. In reality, we receive a warning that the metal is getting overloaded and will ultimately fail. Slide 9. The useful strength or stress relationship of carbon fibre is linear, as can be seen on this straight line of the graph. Consequently, very little warning of failure is given. Slide 10. For steel, failure may simply be defined as the ultimate failure strength, FTU. For composite materials of carbon fibre, glass fibre and Kevlar, etc., we may define failure in a number of ways. By the matrix, i.e. resin failure. By fibre failure. Failure defined by maximum load carrying capability, with composite failure defined by stress, strain or shear failure theories. There are more exotic failures also used, such as Hoffman index, Psi-Wu, Psi-Hill, first ply and last ply failure. Slide 11. Aluminium and steel are equally stiff in all directions, that is, they are isotropic materials. When we talk about stiffness here, we're referring to Young's modulus. Slide 12. Steel has a typical Young's modulus of 208,000 newtons per millimetre squared. Aluminium, 69,000 newtons per millimetre squared. And the carbon fibre as a fibre is over 200,000 newtons per millimetre squared. Composite stiffness can be tailored in a specific direction, whereas steel isotropic materials cannot be. So this is one of the advantages, one of the merits of composites, that their stiffness and strength can be tailored. There are different types of carbon fibre, all offering different stiffnesses and strengths, but typically carbon fibre alone has a similar stiffness to steel, but at a fraction of the density of steel. Slide 13. Failure of steel and isotropic materials is usually defined by an ultimate strength criteria. But failure of composites, as discussed already, can be defined in a number of ways. A particular failure mode of composites is that of delamination. This is where the individual stack of layers start to separate from each other, just like the pages of a book when it's loaded. This condition of delamination can be the cause of premature composite failure. Composite components can delaminate for a number of reasons. Now, there are design methods that exist to minimize the risk of delamination. There's a variety of inspection methods, technologies that exist to inspect composites and identify areas of composite delamination. It should be noted that for aircraft, there exist approved methods of composite inspection and composite repair. A useful advantage of composite materials is their corrosion resistance. In wet conditions, where metal structures will require regular maintenance, example painting, composites will not require that treatment. Composites can resist damage from the weather, salt spray, and even harsh chemicals. Slide 16. Kevlar, in particular, and glass fibre have very good qualities of impact absorption. This is defined by their strain energy absorption characteristics. Kevlar, in particular, is used in bulletproof vest. Kevlar is also used in jet engines around the periphery of the fan blades to act as a containment wrap in case of fan blade off conditions. Slide 17. In certain circumstances, such as for aircraft interiors and equipment racks in trains which go through tunnels, certain specialised composite materials are needed to meet the Fire, Smoke and Toxicity legislation, FST. Composite components in these cases may use a phenolic resin. Epoxy, polyester and vinyl ester resins produce toxic fumes in a fire and do not allow sufficient time for people to evacuate a place which is under fire. Slide 18. When carbon fibre is placed next to aluminium, for example, a galvanic cell is set up and corrosion of the aluminium can take place. Glass fibre is an electrical insulator and is placed between the metal and carbon fibre to prevent galvanic corrosion. Glass fibre composites do not conduct electricity, and carbon fibre is electrically conductive. An interesting property of carbon fibre, it becomes magnetic when electrically charged. The thermal properties of carbon fibre and other composite materials can be significantly different than metals. The thermal conductivity for glass fibre and carbon fibre is lower than that of aluminium or steel. In plane thermal expansion for glass fibre and carbon fibre is significantly lower than that of aluminium or steel. Thermal properties such as the coefficient of thermal expansion should be considered when there exists a possibility of thermal mismatch between composites and metal parts which are joined or within the same structure. Fatigue, acoustic and creep performance for composites can also be tailored, but with an effect on component weight. When tailoring composites, component weight will always change. Strength and reliability with reference to fatigue for composites is good. Slide 23. Other issues to consider. Extremely important, resins such as epoxy have a limiting temperature capability, after which the resin will begin to move, i.e. go soft. This temperature is known as the glass transition temperature, and this is usually written as Tg. Important. I love the challenges of engineering, especially when I hear it said that it can't be done. But we always need an income, so the product as a composite, although it meets the performance requirements, importantly, it must offer financial viability. As engineers, we want to make useful products, and we need to get paid for doing so. So you can increase your own knowledge here, expand it, do your own research for more information on composite properties. Check out composite design and stress modules at highpeakcourses.com. Lecture 3. This will include a definition of composites, material properties, layered composites, composite tailored properties, and the most important question from a composite fabricator, the most important question from a student engineer, 3 essential composite properties you need to know before you start your design. The influence of manufacturing method, the first step in design with 2 examples given.